Okay, so this is chapter 8, number 28, part 2. We found two formulas that use theta. But our question is, okay, there we go. What's the velocity? That's unknown. What's the tangential acceleration? Unknown. And what's theta? We have too many unknowns. So, what we need is another formula that either has both theta and velocity, or another formula that has both theta and tangential acceleration. So let's try a conservation formula. So there are two: conservation of momentum and conservation of energy. Now, there's no collision. There's no collision anywhere, so we can't do the conservation of momentum formula. So let's try the conservation of energy. The conservation of energy means that there's a drop in height of some sort. So the gal started straight at the very top with that radius, and then moved over here. Whoa, okay. It's bad. Alright, there we go. That radius. So there's been a change in height of this much. Right there. That's the height difference. So if we know the height changed, we can figure out the velocity. Okay. We know that this is theta, or theta is what we're trying to find, really. So, to find the drop in height, h equals r minus cosine theta. How did I get that? Well, here's the right triangle. R cosine theta is this piece right here. R is this whole thing. So it's this whole thing minus this piece, cosine theta, will give us h. Okay. So, supposing that at point 2, the height is 0. So over here, height is 0. So there's some height here. If that's the case, we have potential energy plus kinetic energy equals potential energy prime plus kinetic energy. And she's moving. She's lost her potential energy. Call that 0. Here she has potential energy, but she's not moving yet. She's at rest. So that's at 0. So we have mgh equals 1/2 mv squared. So solving for velocity gives us square root 2gh Now, the height we've found in terms of r, and that's good because it's okay to have r formula. So let's rewrite this. This is actually square root 2g r minus r cosine theta. Okay. Now that we have that, we can look at the original formula. The original formula up here, we had v, velocity. Now we can replace it. Here's theta. That's right down here. So mg cosine equals m v squared over r. We're going to replace v with this, and the mass stays the same, so we have to worry about the mass. So we get g cosine theta equals v squared. Notice something. Hey, this whole thing was square root, so hey, I'm just going to make it 2g r minus r cosine theta all over r. And something else goes away. Okay. Very close to the end. So theta cosine theta equals r minus 2 r cosine theta all over r. These r's go. Nice. So now we have cosine theta equals minus 2 cosine theta. If you do algebra, you get cosine theta equals 2/3. 2/3. Because this is 3 cosine thetas. Okay, so theta equals inverse cosine of 2/3, which comes out to and I don't have it, but okay, comes out. All right. Well, whatever it comes out to, that's your answer. Okay. All right. And that's how you solve that one.